Welcome to Vehicle Readiness for the OBD2 test presentation. The purpose of this presentation is to cover types and uses of vehicle monitors, how to check vehicle readiness for pass-fail determination, and how to avoid readiness issues. Terms to know include drive cycle, a set of driving conditions required to run all vehicle monitors. Drive cycles vary by make and model. Trip, a key cycle, key on, start to run, and key off that enables a vehicle monitor to run. And enabling criteria, the exact conditions needed before a test can run. These are provided by a trip. Enabling criteria are the operating conditions that must exist for a monitor to run its tests. These operating conditions include engine temperature, load, and RPM, the vehicle's speed, and other factors that affect the operation and emissions of the vehicle. A trip is a portion of a drive cycle that satisfies a particular monitor's enabling criteria, while a drive cycle contains all the enabling criteria necessary for all monitors to run. A vehicle monitor watches for systems to operate incorrectly so that the powertrain control module, or PCM, can set a diagnostic trouble code, otherwise known as a DTC. Vehicle monitors are broken into three categories: continuous, non-continuous, and not supported. We will cover these categories in detail shortly. The onboard diagnostic system monitors the emissions control system. Those self-tests are broken up into 11 groups, or monitors, for gasoline vehicles. As you can see, most monitors are considered either continuous or non-continuous. Continuous monitors are always running when the engine is running over 500 RPM. These monitors check all systems. The misfire monitor looks for misfires. The fuel system monitor makes sure there's pressure in the fuel line. The comprehensive component monitor includes all other components that make the car run. Every sensor that is necessary for the engine to run is lumped into the comprehensive component monitor. When you plug in your scan tool and start the car to test for readiness, the continuous monitor may show as complete, ready, done, or yes, depending on the scan tool. Regardless of the term being used, the status on the readiness display never changes. Continuous monitors are always supported. If you see a continuous monitor that comes up as not ready or not supported, that suggests that the car has been tampered with or has a manufacturer defect. The misfire monitor checks to see if a cylinder is misfiring by looking at a combination of crankshaft position, CKP, and the anti-lock brake system, ABS, speed sensor feedback. The misfire monitor picks up misfires from both common causes, fuel injectors and spark plugs, and rarer ones, technical and timing issues. If certain failures occur during 2 consecutive trips, a DTC is recorded. The fuel system monitor looks to see if the vehicle is running excessively rich or lean. This is heavily dependent upon the upstream oxygen sensor data, which the PCM uses to adjust fuel trim. A car with a lean condition makes the PCM issue a rich command, increasing the fuel trim into positive territory, while a car with a rich condition makes the PCM issue a lean command, decreasing fuel trim into negative territory. Minor PCM tweaking of fuel trim in the short term is normal. Long-term fuel trim plus or minus 10 indicates a fuel control problem. The Comprehensive Component Monitor, CCM, is an onboard strategy designed to monitor a failure in any electronic component or circuit that provides input or output signal to the powertrain control module, or PCM. It is not exclusively monitored by another system. Inputs and outputs are considered inoperative when a failure exists due to an open circuit, out of range value, or a failed rationality check. The components monitored may belong to the engine, ignition, transmission, air conditioning, or any other PCM-supported subsystem. Inputs monitored by the CCM may include mass airflow, MAF sensor, intake air temperature, IAT sensor, engine coolant temperature, ECT sensor, throttle position, TP sensor, camshaft position, CMP sensor, air conditioning pressure sensor, ACPS, and fuel tank pressure, FTP sensor. Outputs monitored by the CCM may include fuel pump, FP, wide open throttle, AC cutout, WAC, idle air control, IAC, shift solenoid, SS, torque converter clutch, TCC solenoid, intake manifold runner control, IMRC, EVAP canister purge valve, canister vent, CV solenoid. If the fault detected affects emissions and is detected during 2 consecutive drive cycles, the MIL is activated. Non-continuous monitors run only after a trip, which you may recall is a specific set of driving conditions demanded by the manufacturers. Not all cars have these, but all OBD2 gasoline cars have at least 3 non-continuous monitors: the EVAP, the oxygen sensor, and the catalyst. Non-continuous monitor systems may or may not be ready, or they may be unsupported if they are not in the car. If the car does not have an EGR, it will be unsupported. Your scan tool knows this and will not expect that monitor to ever get ready. If your car has EGR, the status will either come back as ready, meaning the system has checked it, or not ready, meaning the system has not checked it. The monitor does not tell you if the system is working or passed or failed. It only tells you whether or not it has had the chance to check it. The EVAP system monitor allows the PCM to test the integrity of the fuel system and its ability to draw fuel vapor into the engine for combustion. During EVAP systems monitoring, the PCM tests for vapor leaks by applying vacuum or pressure to the fuel tank, vapor lines, and charcoal canister. If the PCM detects no airflow when the EVAP canister purge valve is opened, or it detects a leak that equals or exceeds the amount of air that would pass through a hole 0.040 inches in diameter, 0.020 inches for models made in or after the year 2000, a pending DTC fault code is stored. If this fault occurs during 2 drive cycles, the PCM will store a DTC and command the check engine light to illuminate. The oxygen or O2 sensor monitor allows the PCM to verify that the O2 sensors are properly calibrated and functioning without noticeable deterioration under normal engine operating conditions. The sensor is mounted in or near the exhaust manifold to monitor how much unburned oxygen is in the exhaust as it exits the engine. Monitoring oxygen levels in the exhaust is a way of gauging the fuel mixture. It tells the computer if the fuel mixture is burning rich, less oxygen, or lean, more oxygen. A lot of factors can affect the relative richness or leanness of the fuel mixture, including air temperature, engine coolant temperature, barometric pressure, throttle position, airflow, and engine load. There are other sensors to monitor these factors, but the O2 sensor is the master monitor for what's happening with the fuel mixture. Consequently, any problems with the O2 sensor can indicate problems with the entire fuel system. The catalyst monitor evaluates the ability of the converter to reduce harmful emissions. When the catalyst in the converter is working correctly, oxygen from the exhaust is used in the breakdown of other components, pollutants, of the exhaust. Under normal closed-loop fuel control operating conditions, most of the oxygen entering the converter is used up in the reaction. The PCM measures the level of oxygen entering and leaving the converter and calculates converter efficiency. This is accomplished by comparing the outputs from the upstream and downstream oxygen sensors. If the converter is functioning, there should be little unburned oxygen left in the exhaust as it exits the converter. It is illegal to put an extension on the rear O2 sensor, causing less exhaust to trickle its way past the O2 sensor, which would read a low, steady oxygen stream in the exhaust and simulate higher efficiency. The EGR system monitor allows the PCM to test the function and the exhaust flow through the EGR system. Not all vehicles have this monitor, but for those that do, the monitor is activated during EGR system operation that occurs under normal operating conditions. There are two strategies for checking the EGR system. One uses a temperature sensor to measure exhaust flow through the EGR system when the EGR valve is commanded on by the PCM. With this strategy, the temperature sensor signal can also identify EGR flow at times it is not wanted, such as during engine idling. Other strategy uses an EGR valve sensor to measure EGR valve position, which then infers EGR flow through changes in manifold pressure occurring when the PCM commands EGR flow. The PCM will successfully complete the EGR monitor if the proper flow of EGR is detected and no EGR flow at idle is indicated. If the flow rate detected is too low or too high or present at idle, the PCM will set a pending code. If this fault occurs during 2 drive cycles, the PCM will store a DTC and command the check engine light to illuminate. Heated oxygen sensors use an internal heater circuit to bring the sensor up to operating temperature more quickly than an unheated sensor, within 20 to 60 seconds depending on the sensor. This also keeps the oxygen sensor hot even when the engine is idling for a long period of time. The faster the oxygen sensor heats up, the quicker the PCM can enter closed-loop fuel control, optimizing catalytic converter efficiency. On most OBD2 systems, the oxygen sensor heater monitor runs concurrently with the oxygen sensor monitor, or continuously when the engine is running. However, the successful completion of the monitors are independent events. During oxygen sensor heater monitoring, the PCM turns the heater strip circuit on and off for each sensor and looks for an expected change in current. When equipped, the secondary air monitor allows the PCM to ensure that extra air is being delivered to the exhaust system during cold engine operating conditions. This extra air helps heat the catalytic converter quickly when the engine is first started. The PCM uses the signal from the upstream oxygen sensor to detect the presence of extra air in the exhaust manifold supplied by the AIR system. Other non-continuous monitors, which do not have their own monitor titles on most scan tools, include thermostat monitor and the PCV monitor. They can be checked through the DTC codes and through the comprehensive component monitor. Not supported monitors include the air conditioning monitor and the heated catalyst monitor. The air conditioning monitor was originally intended to detect refrigerant leaks in vehicles using older Freon types. However, when air conditioning units started using the new kind of Freon and consuming less power, this became irrelevant and the air conditioning monitor stopped being supported. The heated catalyst monitor was originally intended to monitor the heating of the catalyst upon vehicle start, like a diesel vehicle, which would burn the startup emissions. However, heated catalysts are no longer used due to their susceptibility to impurities, which may decrease their lifespan. Items which may prevent a monitor from being set include the battery or alternator voltage, the engine temperature, the ambient temperature, the altitude or barometric pressure, the crankshaft relearn, the diagnostic trouble codes, any pending DTCs stored in the system, or the vehicle's fuel level. Generally, it is recommended that the vehicle have between 1/4 and 3/4 of a tank of fuel so that the system can gauge the pressure within the fuel line. As a reminder, continuous monitors run continuously and are never really not ready. A scan tool may read the readiness status of a CM as either done, complete, yes, or ready. Readiness status for completed non-continuous monitors is indicated as ready, while monitors which have not yet run are shown as not ready. Not all vehicles are equipped with all monitors. Monitors that are not equipped will display as NA, not supported, or unsupported. Even the same year and model cars may have different monitors. Monitor readiness is lost when DTCs are erased with a scan tool, or the PCM loses power long enough to erase the Keep Alive Memory, KAM, All non-continuous monitors reset to a not ready status. Now that we understand what monitors are and how they work, we can talk about readiness. The readiness test is essential in determining a car's health, as it verifies if the car has completed its self-tests. So when you plug your scan tool in the car, you are checking to see if all the supported systems are ready, meaning the car has checked the systems. If the vehicle reports that there are more than 2 systems that are not ready for testing, you have to reject the car for readiness issues. Without checking for readiness, the computer cannot determine if there are problems with the emissions-related system. Monitors run self-tests on the emission control system to determine the readiness of each system. Readiness status identifies whether the vehicle's computer has completed the required tests of each supported system since the last time the vehicle was serviced with a scan tool or had its battery disconnected. If a system test has been completed, the readiness status for that system monitor will be reported ready. An incomplete monitor will report as not ready. Non-continuous monitors that are not used in the vehicle will report not supported or unsupported. Remember, the readiness status of a monitor does not tell you if there is something wrong with the system, only whether the system has completed its self-tests. An upcoming change to the Vermont AVIP is that a vehicle will fail for readiness when a conditional pass goes away. Vermont's annual vehicle inspection program allows a pass-fail decision to be made even if up to 2 system tests or monitors are reported as not ready. When conditional pass goes away, a vehicle will not pass the OBD2 inspection unless the required number of monitors have been completed and reported as ready. Readiness means that the system is communicating and that any presented problems will be reported under diagnostic trouble codes. Once a monitor is ready, it stays ready, unless someone disconnects the battery, the voltage to the computer goes down, or someone erases the DTCs. A system monitor may come back as not ready if the DTCs were recently cleared, so be sure not to clear the codes prior to checking for readiness. The system monitor may also be not ready if the battery has been recently disconnected or discharged. Software updates may also reset the computer systems, resulting in the systems to be not ready. Do not use a scan tool or disconnect the battery to turn off the check engine light in an attempt to pass the OBD inspection. This practice is counterproductive because it will lead to readiness failure. Please let the public know this as well. To get the vehicle to reset its system tests to ready more quickly, it can be driven in a drive cycle, in which a set of operating conditions are met in a specific order. A vehicle's specific drive cycle depends on the vehicle's make and model, and which system tests need to be reset. Many vehicle manufacturers include these drive cycles in the vehicle's owner's manual, in technical service bulletins, TSBs, or through other information sources commonly used by the automotive repair facilities. There are online resources available, such as OEM service information portals, and a readiness drive cycle book, which can provide the vehicle-specific drive cycle information. The following may assist with resetting a vehicle to ready more quickly. Drive the vehicle at least 3 separate times in which it is turned on and off. After a cold start, allow vehicle to idle for approximately 3 minutes. One drive cycle should be local in-town driving. One drive cycle should be highway driving. One drive cycle should be after the vehicle has been parked for at least 8 hours without starting the engine, for example, overnight. The fuel tank should be 1/4 to 3/4 full. Typically, driving a vehicle in normal conditions for a day or 2 without resetting the DTCs or disconnecting the battery will give the system enough time to complete a drive cycle and get all of the vehicle's monitors ready. To figure out the correct drive cycle for the vehicle's make and model, use resources such as AllData, Mitchell, Motor Information Systems, OBD2 Drive Cycle Book, or another resource. Remember that many owners' manuals will have the drive cycles listed in them. These following slides offer tips for avoiding readiness issues. First, remember not to clear diagnostic trouble codes prior to making the necessary repairs. This prevents the check engine light from coming back on after the repair. The computer system will automatically turn off the check engine light while driving the vehicle through its drive cycle if the fault is no longer present, showing the vehicle is ready to be retested. If the check engine light does not turn off, additional repairs may be required. Second, recommend that the customers get their vehicles inspected early. Waiting to the last minute may not leave enough time for a vehicle to get ready or to undergo repairs. Customers have a full 60 days to have their vehicles inspected, and the sticker lasts a full 12 months after the end of the 60-day inspection period. Finally, if the check engine light comes on, getting repairs done early will save money in the long run. Replacing a misfiring spark plug is significantly less expensive than replacing a catalytic converter that was damaged because the motorist ignored the initial repair issue. Getting the repair done when the light comes on saves the consumer money. True or false? The catalyst monitor may switch from ready to not ready if a fault with the oxygen sensor is present. The answer is false. Once a monitor becomes ready, it will remain ready unless DTCs are cleared using a scan tool or the battery is disconnected. True or false? It is a good practice to ensure a vehicle has a full tank of fuel before completing a drive cycle. The answer is false. Many vehicles will require the fuel level is between 1/4 and 3/4 in order to run some monitors. Final question. How many not ready monitors can a vehicle have and still pass the inspection? The answer is 2. OBD2 vehicles may have up to 2 not ready monitors and still pass the inspection if all other criteria are met.